So in this tutorial what we're going to do is take a look now at how we can use a multimeter to actually test that our circuit is working before we were able to plug it in. Obviously this one doesn't get plugged in, but you know, I think you get the idea. So a multimeter provides lots of different ways of metering different things. That's why it's a multiple meter. One of the things it can measure is voltage in DC circuit. It could also measure AC voltage, that's the mains. I don't suggest you do that, of course. You can also measure the amount of current that's flowing through a circuit. It'll also do some work on transistors for you. You can test diodes and also can measure resistance. What we're really interested in for this tutorial though is just this setting here for resistance, and we'll use this one for diodes, which we can also use to test what we call continuity, or whether or not two things are touching. So the first thing I'd like to check, I think, is that all my resistors are working properly. If we remind ourselves what our circuit looks like, I'm going to sort of balance it on here for this tutorial. You can see here that what I should have is a series of resistors. I've got a 330, 2200, 470 and an 18k or 18,000 ohm resistor in the top. I'm actually going to test each of these one at a time, and then I can test that all of them are okay, and then we'll do continuity last. So to use the multimeter, the way that you do it is you start by setting the dial to the next value up from the value you're expecting to see. Okay, so let's look at an example of that. My first resistor is 330 ohms. So if I set it to 200 ohms, that wouldn't be enough because I'm expecting 330. So 2000 is the next value up, so that's what I set it to. So I'm going to spin the dial around to 2200. What I also need to do is to connect up my probes. You should have a black and a red. The black probe goes here into common, so plug that into there. I should wash my hands before I start these tutorials. Okay, so black one goes into common, like so, and then the red one just here goes into the next one up. You don't want to put it into the 10 amp one, that's for when you're testing really high voltage stuff. It just needs to go into the one that's for voltage, resistance and current, just here, look. Okay, so I'm going to push that into there. Lovely job. The first thing you should always do actually before you do start doing anything is to make sure the multimeter itself is actually working and the probes are connected. The way I'm going to do that is by putting it onto this diode setting or continuity setting just here and looking at the number up at the top of the display. It's currently showing a 1, and all that means is that at the moment it's not detecting anything. But if I take my two probes and I touch them together, then the multimeter will detect that those two things are connected together. You see the numbers changing all the time. It just tells you how much resistance it's detecting. It's not really all that important. What is important is that the number changes. So that tells us that two things are touching. So we know our probes are connected up correctly. Back to resistance. So moving that dial around, I'll show you the number. I'm also going to put the PCB as well just on here so you can see that. And all I'm going to do is touch one probe either end of my resistor. Doesn't matter which end goes where for a resistor, but that one's going to go in there, so I'm sort of holding it down with that. And I touch the other one on here. For some reason, that thinks it's on HV setting at the moment. I made a common mistake. My arrow is pointing at high voltage. It's the joys of videoing through a camera rather than looking at what you're actually meant to be doing. Okay, back to where we were. So at the moment we're getting a reading of 1 because it's detecting nothing because nothing's touching anything else. First one in, pinning it in place. Second one goes on and I'm getting a reading of, hold on, 328 ohms. Okay, so bearing in mind that we're using 5% resistors, then we're expecting to see anything 5% either way of 330, so approximately sort of 16 ohms either way would be fine, so that's well within tolerance. So we know the 330 ohm resistor is okay. The next one is a 2200 ohm resistor, 2K2. If we look at our different options, 2000 is less than 2200, so we have to dial it up to the next value up, which is 20,000 ohms, and again we can test that again now. So let's just pop that back in place and get the probes on. So first one going on, second one going on other side, and we're getting a reading of 2.19. So we'd be expecting to see basically 2.2, but 2.19 again is well within the 5% range that we're allowing. Let's look at the next resistor. That's a 470 ohm resistor, so we can dial it back this time to 2000 ohms. And let's do the next one. And get that in there. 468, good, that's within tolerance, and the last one is 18k, so let me just do that, so I'll turn it up to 20k for that one, and let's get that in there. 17.86 is pretty close to 18k, so I'm happy with that. Another thing that you could have done, if we think about it, is I could have actually measured the resistance across all of these resistors. The way that this little circuit here is actually set up is I've chained all these together. So this leads to this, that's directly connected, it's a tiny little track in there, look, to this one, these two are connected, it comes across, these two are connected, it comes across. It then actually travels down through that repair that I've done, along here, around this corner, through that multi-link, through the single link, all the way over here. So actually, in theory, I should be able to measure the resistance from this point to this point, and it should add up to 21,000 ohms, 21k. That's what all these numbers, when they're added together, come up to. So we could actually test that, and if it works, and if it tells us that, then we know that our two repairs were definitely both okay. You know, we know that these must have been okay because current's travelling through them, and we know that our multi-link must have been okay because the current has to travel through that, and we know that our single link must have been okay because current has to travel through that as well. So that's a really good way to have actually saved me doing all those other tests that went before it. I could have just done that straight away, and that would have told me if the entire run was okay. As it happens, we did it this way just because, you know, we're learning how to use a multimeter. So let's go ahead and do that. 21k, so 20k is too little, so I'm actually going to turn it up to the next, which is 200k. And you can see the screen, let's balance that in there as best I can. I've been lucky so far. Normally when I try and do this, the circuit runs away from me, but I seem to be getting, like I say, quite a good run of luck. So let's get the first probe in, that's just there. Let's get my second probe in, that's just here. And see, this is what happens. Okay, let's try and get a good grip on that first one again. No, maybe I can get a better grip on the second one. Good thing to do is to get someone to help you. That's always nice. Here we go, we're there. 21.2. Okay, 21.2 is well within the 5% that I was looking for. So actually we know this entire run is all okay. Another way I could have done that, if I'd had any problems at any point, and I was trying to sort of troubleshoot and work out where the issue was, is I could have used that diode setting just to work out what things are connected. So I could imagine that a time where perhaps I wanted to make sure that my first of my track repairs was definitely okay. My first track repair being perhaps this one just here. So I could touch on the track either side of that. Okay, let me just try and get a good clean contact in there. There you go. Touch on the track either side of the track of the repair, and it comes up, tells me I've got 1 ohm of resistance over that wire, which is about right. Let's try another link as well, see if this this repair here was any good. That one was okay as well. Check my multi-link. Yep, that's okay. Check my last of my single links. And again, that was okay, but we knew it was already because we did that by doing that last resistance check. So that's a couple of different ways that we can use a multimeter. There's some other ways you'll look at once you get a bit more experience, which include using the DC setting, okay, which we can use to measure the amount of current in a circuit. The sort of thing you can test on that if you want to have a little play in advance is you could always connect a 9-volt battery up, to the ends of the probes, and you could stick those in there, in a 9-volt battery, and you'd expect to see that come up with 9 volts, as long as we've got this set here, of course, to 20 volts, which is the range that you'd expect for that. Okay, so make sure you can use a multimeter because the teacher might ask you to demonstrate doing it, and once you're happy that you've got a working soldering license, then very, very well done you. You've completed that particular task. You can then use this nice big hole just here, stick it on your keys, and you can keep that as a little souvenir and to demonstrate that you're a good solderer. Okay, I'll see you in the next tutorial.